Colistin is a potent, last-resort antibiotic, used only to treat people with dangerous, life-threatening bacterial infections that have developed resistance to other drugs. But it's not foolproof. Worldwide, resistance to colistin is spreading, further diminishing treatment options and putting infected people at higher risk. Researchers from the University of Georgia recently identified a way that colistin-resistance genes are spreading: imported seafood. In a new study, microbiologist Issmat Kassem, Ph.D., and his group have reported the first isolation of colistin-resistance genes in bacteria found in imported shrimp and scallops, purchased from 8 food markets around Atlanta, Georgia. Kassem will be presenting the findings this week in Los Angeles at ASM Microbe 2025, the annual meeting of the American Society for Microbiology. An accompanying paper will be published in the ASM journal mSphere. "We love our seafood," Kassem said. "Many people don't know that most seafood consumed in the U.S. is imported," he said, including about 90% of shrimp. Imported seafood is screened for contaminants, but the process doesn't catch everything, especially antimicrobial resistance genes. The bacteria that were carrying colistin resistance genes are not normally screened. Kassem and his group also found that some of the resistance genes are carried on plasmids, round bits of genetic material that can be transmitted from bacteria to bacteria. Antimicrobial resistant infections kill hundreds of thousands of people globally every year, and antimicrobial resistance is a rising public health menace. Colistin was first introduced in the 1950s to treat infections by pathogenic gram-negative bacteria, but it takes a heavy toll on patients, including increased risk of damage to the nerves and kidneys. It was discontinued in the U.S. in the 1980s. However, Kassem noted, other countries continue to use it in agricultural settings, both to treat infections and to promote animal growth. Colistin was eventually reintroduced to human medicine because it was one of the few options available to treat certain bacterial infections. The World Health Organization categorizes colistin as a high-priority, critically important antibiotic, which means it is an essential option for treating serious human infections. In 2016, researchers discovered a mobile colistin-resistant gene, or mCR, that was mobile because it could be transferred via lateral transmission in plasmids passed among bacteria. Before then, Kassem said, researchers believe colistin resistance was inherited, not shared, which means it could not jump between different bacteria. Researchers have now identified at least 10 mCR genes and many alleles, or variations. Kassem, who has been studying antimicrobial resistance for 2 decades, suspected it might spread through the importing and exporting of food. "Our food is sourced from different places," he said. "If you go out to lunch today, your plate might have ingredients from 6, 7, 8 countries. Some countries do not have strict regulations for using antibiotics in food animal production, so imported food can be a vehicle for transmission of resistance." In previous work, his group found mCR genes in samples from wastewater in Georgia. They also found the bacterial host that was carrying the plasmid containing the genes. It wasn't normally screened in food coming into the United States, he said. In studies published since then, researchers have found mCR genes in plasmids elsewhere. When they screened seafood purchased from markets in Georgia, they found the same bacterial host, the same plasmids, and the same genes that they'd previously identified in wastewater. "The good news is that we didn't find it in locally produced seafood," Kassem said. He cautioned that the group identified one source of colistin resistance, but there could be other, and they're likely spreading. "We live in a very connected world," he said. "We move a lot, we travel a lot, our food travels, and we are going to spread whatever emerges, even across national borders. So, it's important to invest in monitoring systems and expand them and collaborate, especially on the global level, on the issue of antimicrobial resistance."